start with number 16. Again, today is 15 through 40. So once you get the hang of one section, you're free to kind of jump ahead if you can see what's going on. This is, I think, easy, but I guess maybe it's been a little bit. So, Allie, looking at 16, you know what? Let's back up one step here. Allie, what's the parent function for 16? And it's absolute value. What's the shape of an absolute value? Like a V. So there's our parent function, and then there's some changes made to it. So, Karis, what's one of the changes? Left one. Reese, what else has happened to this thing? Up 2. And Cole, what's that 3 out front do to the graph? Good. Vertical stretch by 3. So, left 1, up 2. There's my new starting point. I'll make a V. So exactly how do I use that vertical stretch of 3? Like, how does that show up on the graph? Multiply the y values by 3. And normally it's just 1, 1, 2, 2, 3, 3. But it's like we have a slope of 3 now. So, whoops, not 3, but 9 there. So over 1, up 3. Over 1, up 3 puts us off the graph. But now we've got a absolute value graph. Moved it left 1, up 2, stretch 3. Let's look at 18. Same 4 questions here. Jack, what's the parent function going on number 18? Quadratic, so what's that look like? Or what's the name of the shape? Parabola, thank you. All right, Ethan, there's been some changes to our parent function parabola. What's one of those changes?
It's like stretched.
Okay, by how much?
1/2.
Okay. So you said stretched, which is okay. Compressed, squished, smashed. You could say stretched as long as you multiply the y values by 1/2. It doesn't really matter what you call it, as long as you squish it. Nicole, what else has happened to number 18? Up 3. And Adeline, what else? What's that last thing? Left 2. Okay, up. Ooh, we got a weird looking graph here. Find the origin first. Down here. Up 3, we're going by halves. That's weird, but okay. Left 2, so there's my starting point. Normal for a parabola is 1, 1, 2, 4, 3, 9, because I'm squaring the x's. But Ethan pointed out that 1/2 earlier. So we got to multiply each of those y values by 1/2. That will accomplish the squish. Again, make sure you only do the y values. If you do both, you end up squishing in both directions, which isn't really a squish. It's just like miniaturizing it. All right, over 1, up 1/2. Over 1, up 1/2. Over 3, 1, 2, 3. No, over 2, up 2. Over 2, up 2. Over 2, up 2. And then we're off the graph on the left. I guess we could go one more on the right. Over 3, up 4.5. 1, 2, 3, 4.5. We're still off the graph, but something like that. So we've got a parabola. And again, take the time to check to make sure your picture matches your words. Like, your words are almost always right. Sometimes the connection isn't made, so take the time. Compressed, up 3, left 2. Yes, we got it. '19 and 20 are sort of backwards, so why don't you try 19 and 20 real quick, if you have. Go over these. So you skipped ahead, which is fine. So parabola, I guess we should make note of that first. So y equals something squared. That's the parabola part. Right 4 would be x minus 4. Up 6 would be a plus 6 at the end. And it's flipped over, so a negative out front.
It's also stretched.
Is it stretched? Oh, you gotta look careful on the stretches, I guess. 1, 1 would be there. 2, 4 would be there. So yeah, it's been stretched. By 2? Yeah. There's a stretch of 2 on that thing. Yeah, 19's a good one because it has all of the problems. So it's number 20 for that matter. Let's see. Left 4, down 2, flip. How would you describe the stretch on this one? Okay. Compression by how much? By a half. Because the slope is now 1/2 rather than 1. Okay, so y equals flipped stretch, that's the negative 1/2. X plus 4 would give me my left 4. And then minus 2 would be down 2. Hopefully that's old news for you guys. At least once it's refreshed in your brain, you remember the rules for transformations. 22 is kind of weird?
Yeah.
Alright, then we'll do 22. I was going to do 21, but we'll make it 22. What did you do first on 22?
I made them normal.
Made them normal. That's a good answer. And by normal, I think you mean y equals mx plus b?
Yeah.
Yeah, let's make them into slope-intercept form. What you think of as normal. So it's fine to call it that because that's what we're doing. So negative 3y greater than negative 2x minus 3. Divide by negative 3. We just did this not long ago. What happens when we divide by negative? Flips the sign, so y is less than 2/3 x plus 1. So let's graph 2/3 x plus 1. There's my plus 1. Slope is up 2 over 3. Did you figure it out?
Yeah.
What else do I need to think about before I start graphing this thing? Dotted line. Because it's not equal to. And then where am I shading?
Below.
Dotted and below. And I need to be careful shading. I don't want to shade too dark because this is going to be an overlap shading thing. So I'll shade below, but kind of lightly because the answer will be wherever the overlap is.
Do you have to shade the spot, or can you only shade the overlap?
Yeah, if you want to wait and only shade the overlap, that's okay. But for some people, it's hard to see the overlap without shading the individual pieces. So, yeah, you can do that if you can figure out where it is. Okay, the other one, 3y greater than negative x minus 6. We divide by 3, negative 1/3 x minus 2. Why didn't I flip the inequality that time? Because you divided by a positive. Right. I divided by a positive, not a negative, so that's fine. Alright, negative 2 for an intercept, down 1 over 3 for a negative slope. Another dashed line. And this time we're shading above. And then I need to do something to indicate where my answer is. I'd like a pencil, but I don't see one. So, what could I do? So just make it a little darker. So the overlap region is right there. That's the answer. And that means anything in that overlap region, any point in there is true in both inequalities. All right, 21, 23, pretty similar. It's been a while since we wrote a matrix equation. It's like the bracket thing. Once you remember, it's not hard because you just pick off the coefficients. If everything's laid out the right way, unlike 25, but if everything's laid out the right way, you just grab the coefficients. For the coefficient matrix, that's not all. X and Y, and then 12 and negative 18. So we've got a matrix equation here. AX equals B. Well, it does say solve. We put it in the calculator where we would do A inverse times B. Did we not do that? Well, so okay, then that's fine because the test, the final is multiple choice, which means you can plug in the answers to see which one works. Or I could have you match which setup matches. So you definitely need to know how to do that, how to write that. But the final is no calculator, so I guess we can just stop there. Uh, 26 and 27 look worse, and I guess they are worse because they're bigger. But this is why we like the matrix version. It's a whole lot easier to do a matrix solve than a by hand solve for 26 and 27. So again, the instruction will change it a little bit. We'll just say set up the matrix equation. So you'll have a big 3 by 3 matrix, X, Y, Z, and then the answers. So it looks, massive and complicated. And I guess it is, but your calculator handles the massive and complicated.
I feel like those, weren't there ones where we had chain equations? We had make equations from word problems?
Yes, there were ones where you had to make equations for word problems. I don't think those are on the final. Yeah, and with multiple choice, even if there was one, you could probably piece it together and figure it out. Thank you. All right, the next set, indicated operations. So operations on functions. So add, subtract, multiply, divide, but this time with functions. No, I don't think this stuff is hard. Caroline? Yeah, let's back up the matrix one.
You always, so you take all the x's, they have to go across or down?
Down. So all you do is you're looking at this, if it's laid out right, and you're just putting those in the same spot that you see them.
Okay, got it.
That's what's nice about it. You don't really make sure you get the signs, and if one's missing, it's 0. But other than that, yeah, the only tricky things are ones like 25 where we put it in the wrong order, so it forces you to kind of reshuffle things around a little bit.
Wait, how are you in the wrong order?
Well, I guess it's not in the wrong order because you can just write it like this: negative x plus 4y equals negative 8.
Can't you just put it in as it is?
If you recognize what's going on, okay. Don't put 8 as part of the coefficient matrix.
Yeah.
All right, 29. What? Especially 29 and 31. What's the difference between that dot and that dot? Because those aren't the same dots.
One is a multiplication, one is F of G. One's like plug and play.
Okay, so the first one's multiplication,
Oh, I did not like it.
and the second one is
Fog. It's like
Fog.
put in the equation for X.
it's f of g of x.
You gotta plug it in.
So we'll plug one of them into the other. Let's back up and do the easier one first, though. Multiplication. Negative 2x plus 3 times x squared minus 1. So that's not really that big a deal. It's like a FOIL problem. First, outside, inside, and last. No like terms, so that's it. It would probably look nicer if we put the terms in descending order. So on the test, it might switch the order of those two terms, but that's no big deal. Okay, 31, f of g of x. I much prefer to write it this way because I'm less likely to mess it up if I do it that way. So, who's getting plugged into the other one, I guess, is the main question. Yeah, G's getting plugged into F. F of 2x plus 3. So that means we go to our F function, and instead of plugging in x, we plug in 2x plus 3. And leave everything else the same. So that's F evaluated at G. Right? F of 3 would mean plug in 3. F of 4 means plug in 4. F of 7 means plug in 7. F of G means plug in G. So 8x plus 12 plus 3 would be 8x plus 15. Yeah, 32 is dividing. So 32 is, yes, that's exactly right. Half the time, including this time, you can't do anything. So that's the answer. There's nothing that will reduce. So that's as good as it gets. Same thing happens on 33. We didn't do a subtraction like 28 or 34, but do you remember what the potential hang-up is with a...
You would multiply the negative into it.
Yeah, parentheses or distribute or however you want to phrase it. Make sure you're subtracting all of G. Don't just write it out. In fact, here's how to mess that problem up. Right, that looks like F minus G, I guess. But you need to subtract all of G. So negative T minus 8. That's the only trouble.
G is the worst variable.
Because it looks like a plus sign.
V and U is the worst. If there's two, it's V and U.
Yes, you're right. If there's two variables, U and V are the worst. There's one, T is bad. Z isn't much better because it looks like a 2.
And others S. Really mess up your S.
But I'll usually cross my Z to... sometimes my B's are bad. Because if you get 6B... Anyway. Minor problems. Next page, more of the same. We got some F of stuff in there. Or G of. Why don't you try 36? Enough me working problems. Let's let you work a problem. Try 36. So plug H into G. 37, 38, more practice. 39, more practice. Let's do 40, because, man, we just kind of glossed over 40 the last time.
Oh,
Wait, I can't remember. Oh, go into go into.
F of G of X, G of F of X. So let's see, F of G of X.
Yeah, like the last
You could
one.
like look at it and know.
So let's start on the inside. So X to G of X to F of G of X. So let's see. So maybe there's a better way than writing all these down. So if X is 4, G of X is negative 3. Is there a F at negative 3 with an input of negative 3?
Yeah, there's 6.
Yeah. It doesn't always work, so you have to just try and see. When X is 2, G is negative 7.
Yes.
Yes.
Negative 8.
Negative 8. Hope they didn't make all of these work. They don't all work.
Not work.
9 gives me 8, but there's no input of 8 for the F function. So I just no solution, doesn't work.
But you get negative 8, and then it's negative 4. No. So the last two don't work.
Negative 4, negative 4. That's my G function, which means I'm looking for an input of negative 4 in my F, and that's a no. So that means that F of G of X it's listed as an ordered pair.
6, negative 8.
No, I want an input and an output. So 4, 6, and 2, negative 8. Because I need an input and an output. That is the last one I would call self-explanatory. Now you do the other one.
Oh wait, there's still more.
Because I've got to find, that was F of G of X, so there's one of my answers. Now I need G of F of X. So start with an X, look at F, see if there's an input. I'm going to press pause and let you try that one, because so I input output for F, but then for G, this is the input, and this is that, and there aren't any outputs because there aren't any of these that are inputs. So G of F of X does not exist.
What do you have to put it in?
You have to put does not exist. You have to put something there. It doesn't work. No solution, doesn't exist, something along those lines. Does not exist is probably best because the way the question is worded, it kind of gives you a hint. If they exist, so the answer is that one does not exist. Yeah. All right, that leaves 15 minutes. If you haven't been working through as we've gone, then that's fine. Now you can kind of go back and maybe finish before we leave. Again, trying to have as little as homework as possible during this week and a half. Make your life a little easier.
I'm trying to make sure that I actually know what
If you're peeking ahead, tomorrow we'll do 41 to 60.
41 to 60?
And if you're really peeking ahead, I've got the
School looking to get one faster.
in the videos. I've got it posted on what day we're doing what, so you can
They should give
peek ahead if you like.
dedicated time for both.